Hi, I'm Dr. Brad Witzel at Winthrop University, and I was a member of the panel for the IES Practice Guide on RTI and mathematics. Visualizations have blossomed as a research piece for struggling students in mathematics. Now, one type of visualization is the concrete to representation to abstract sequence of instruction. It's called CRA. The concrete part of it is a physical manipulation. The R is a pictorial representation of that physical manipulation. The most important part to CRA is not those two, it's the A, abstract. It is the sequence of steps I'm trying to teach the students to learn. In fact, to set up a CRA sequence of instruction, I actually devise it all based on the abstract. Let's say that I have a 5-step problem abstractly. That doesn't mean I teach concrete different. It means my concrete must present a 5-step sequence. It means the R, the picture, must present the 5-step sequence. So I'm giving students a kind of a scaffolded, leveled approach to learning a sequence of instruction. If we're trying to teach fractions with unlike denominators, I should have a concrete visual that the students are interacting with. So if I'm doing 1/2 plus 1/3, they should be able to manipulate the 1/2 and 1/3 to figure out those multiples. That would be the concrete part of it. And they'd follow one series of steps. The pictorial part, they're actually drawing out the same concrete ideas and again following the same sequence of its steps. Finally, at the abstract level, they're doing it with the numbers written in Arabic symbols, and they're doing again the same sequence of steps. The beauty to CRA is not because it just takes students in a different direction. In fact, the students through CRA only learn one thing, and that's important. A lot of times you get concrete objects, the students learning one thing, and by the abstract they're learning something different. We don't want that. So CRA is one big way of doing visualizations. For concrete to representation to abstract sequence of instruction, there might be some confusion out there as far as, well, how long do I do each level? And it's actually, that one's easier than usual, than most of my answers. You do it until the student is proficient at that level. So I would do a concrete instruction until the student shows that they can accurately go through the steps. Then we go to a pictorial form. And it's funny, the students go, well, can I have those concrete things back? And I work with a lot of high school students who, a lot of teachers go, well, they don't need concrete. Absolutely they do. And they'll say, can I have those back? Well, actually, no, you're good at this now. Let's do a pictorial form of it. And once they are, again, proficient at the pictorial level, then we go to the abstract level. The goal of CRA is to get to the abstract level, but you want to make sure by the time they get there that they're ready to succeed at that level. There are many visualizations in mathematics that are possible. One are number lines. The use of number lines is not just for teaching counting and counting back and counting on. The use of number lines can be used all over mathematics, from teaching arrays to teaching vectors later on. We can use number lines for simple integers. We can use them for fractions and locating fractions on a number line. We can use them for decimals. There are a lot of different uses for that kind of visualization there. Another possible one is strip diagrams. Strip diagrams are very useful for word problems. A strip diagram could help you show a missing addend or another type of word problem. But typically there's a schema that's attached to it, or a learning process that's attached to using a strip diagram with a word problem. Now, the good news is, in the IES Practice Guide on RTI Math, there are lots of examples to peruse. And that way you can go through them and really look through which one of the details and how to use them. They even have explanations of how to use each one of them.